This is the alternate segment theorem. In this video, we're going to find out what it is and where it comes from. If you find this video useful, please consider leaving a like, a comment, and subscribing to our channel for more content like this. Circle theorems are sets of rules that describe the relationships between angles, lines, and arcs within a circle. They provide a framework for understanding geometric properties within circles, and are useful for solving problems involving circles. The circle theorem we're going to investigate here is called the alternate segment theorem. This theorem is illustrated in this diagram. The theorem tells us that in any circle, the angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment. That sounds a bit technical, so it makes more sense when we look at this diagram. We've drawn a circle with centre O and points A, B and C marked on its circumference. The angle ABC marked Y on our diagram is the alternate segment of the angle marked X because it's on the other side of the chord AC. And the theorem states that angles X and Y are both equal. In this video, we'll show why X and Y are both equal. But before we go any further, let's define those two terms, a tangent and a chord. A tangent is a line that touches the circle at exactly one point. An example is line DE in this diagram. And a chord is a line segment that connects 2 points on the perimeter of the circle. AB and BC are both chords on this diagram. Now, let's look at two important angle facts you may already know that we need to be able to show why X and Y are both equal. This diagram shows that the angle made at the center of a circle is twice the size of the angle made at the circumference when they originate from the same 2 points, A and C. In the context of this diagram, that means angle AOC is twice as large as angle ABC. A tangent to a circle is perpendicular to the radius drawn at the point of contact. In this diagram, that means angle OCD is equal to 90 degrees. We'll need to use both of these facts to help us prove that X and Y are equal. To begin, we're going to draw a line from A to O, the centre of our circle, and a second line from C to O. These lines are a radius of the circle and as a result, are both equal in length. We can indicate that on the diagram. The triangle that we have created, AOC, is an isosceles triangle, since two of the sides are equal in length. Next, let's draw a line perpendicular to the base AC, dividing our isosceles triangle, AOC, into two equal right-angled triangles. We've now cut angle AOC into two equal halves. I'm going to label these angles with the letter Z, since they're both equal. Inside each right-angled triangle, I'm going to label the acute angle in each corner with the letter W, since both of these angles are equal. Remember from the earlier rule that angle AOC is double the size of angle ABC. That means Z plus Z is equal to 2y. We can rewrite this as 2z is equal to 2y. And therefore, by halving both sides, z is equal to y. We also saw that angle OCD is 90 degrees. So, that means that angles x plus w must also equal 90 degrees. Looking at our right-angled triangle, we can also see that given the sum of the angles in a triangle is 180 degrees, z plus w must equal 90 degrees. And given that we already found that z is equal to y, this can be rewritten as y plus w is equal to 90 degrees. If x plus w is equal to 90 degrees and y plus w is equal to 90 degrees, it follows that x plus w is equal to y plus w. And subtracting w from both sides gives us x equal to y. So, x and y are both equal. And that's the alternate segment theorem. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.